Today's lesson on transformations is translations. So we have a lot of vocabulary for transformations. So a transformation is a function that moves or changes a figure to produce a new figure. A rigid motion or isometry is a transformation that preserves the length and the angle measure. So my transformations are congruent. And usually we refer to this as same size and same shape. Not sure why that happens. So same size and same shape. A translation moves every point of the figure the same distance and the direction by sliding. The pre-image is the original or the first figure. So the pre-image prefix pre means before. Okay. Image is the next figure or the second figure, and that is my copy. And I can tell which one I have by I add what I call a prime symbol. So the first one has no prime. The second one has a prime. The third one, which would be the second copy, has 2 primes. And the third copy has 3 primes. So a vector is a quantity with a direction and a magnitude, represented by an arrow, starting at the initial point, which is the beginning, and ending at the terminal point, the end. So a vector, we use these arrow symbols. So they're not quite like a coordinate, but they work similar. So the first number in my vector, I'm moving left and right, and my second number, I'm moving up and down. So when we are working with these, so my first letter is horizontal, and my second letter is vertical, just like graphing. So let's compare these. These look really similar. So the only difference that I see are the symbols that I'm using on the outside, okay? Otherwise, they're very, very similar. And instead of using the variables x and y, I use the letters A and B for vectors. Okay, so let's start out with the first part, the component form of the vector. So we want to name this vector and write it in component form. So I know H is the initial side because S has the arrowhead. So I name this as vector HS, which is similar to what we've been calling array. And in component form, I start here and I'm going to break it down into a horizontal and a vertical. So I am going +3 to the right and 1, 2, 3, 4 and +4 up. So this is going to be vector 3, 4. So I know I went to the right and I went up. And I always have to start at the initial side, not necessarily the one on the left. Okay, so let's translate using a vector. I want to translate triangle ABC through vector 5, -1 on the coordinate grid. So I'm going to move 5 units to the right and 1 unit down. So this is telling me 5 units to the right because it's positive, and 1 unit down because I'm negative. And then I want to label the image with the primes. So this is my first, or the original, so I call this the preimage. Okay, so I'm going to take each point and go to the right 5. 1, 2, 3, 4, 5, and down 1. So I call that A prime. 1, 2, 3, 4, 5, and down 1. And that is B prime. 1, 2, 3, 4, 5, and down 1. That is called C prime. So I can't call them A, B, and C because I already have an A, B, and C. And then next, when we're done, the vector, you can kind of see the vector when you connect A to A prime, B to B prime, and C to C prime. So my new figure is called the image. It is a copy, but the academic word for that is image. I can also tell you what the coordinates are by translating a polygon MJE through vector 3, -1. So I know A is 3 and B is -1. So here's A and B. So to translate my image, I add A to the X coordinate and B to the Y coordinate. So my A is 3 and my B is -1. So when I add these, my new image M prime, so I'm adding these. So my M prime, so -3 plus 3 is 0, and -1 plus -1 is -2. So I add the vector. So this is 3, -1. So my new point called my image. So this is my pre-image. And this is my image. So my original point, my pre-image is called J. So my image is called J prime. And the coordinates are 5 plus 3 is 8. And -3 plus -1 is -4. So E, my last point, I'm going to add my vector, 3, -1. So my pre-image is called E, and my image is called E prime. So -2 plus 3 is 1, and -2 plus -1 is -3. Okay, so if I'm given the image and the pre-image, I also want to know, how do I write the rule? And I want to write it in vector notation and coordinate rule notation. Okay, so first I kind of want to decide which one is the pre-image and which one is the image. And I can tell because I see the prime on these coordinates. So that tells me this is the pre-image and this is the image or the copy. The academic word is image. So I know my vector when I'm connecting, I'm going from E to E prime, T to T prime, or O to O prime. So I need to know the direction of the vector. So I can choose any one of them. So I'm going to pick from E to E prime. So I'm going to break it down to horizontal and vertical. So I know I'm going to the left, 1, 2, 3. So going to the left is negative, and then I'm going down 1, 2. So going down is 2. So my vector is -3, 2. So to write this as a rule, I say my coordinate xy becomes x minus 3 and y minus 2. Okay, so I'm substituting A and B in here. Okay, my last example is I want to determine what the vector is. When I gave you the preimage and the image as coordinates. So to do that, what we're going to do is we are going to take the image and figure out what the vector is. Okay. So I'm going to start with, and I know that to go from my pre-image to my image, -3, -1, I'm going to add b. So I'm thinking about this as an equation. So I'm saying -5 plus a equals -3. So if I add 5 to both sides, I get a equals 2. So I know my vector a equals 2. And I'm going to do the same thing with the b value. So I know I am going to add 5 plus b equals -1. So if I subtract 5 from both sides, I get b equals -6. So I know a, my horizontal value is 2, and b, my vertical value is -6. So my vector is 2, -6. And if I want to check, I can just substitute that back. And so if I say -5 plus 2, I get -3, and 5 plus -6, I get -1. So I've checked. Okay, that's it.